7-digit number with a missing digit, and it's known to be divisible by 13. You're given that information. We're telling you that it's divisible by 13, and of course we're supposed to find the value for D. Now, y'all, this is base 10, so of course the possible digits for D would be 0, 1, 2, all the way up to 9. Base 10, that's how many digits you have. You have 10 digits starting at 0, ending at 9. Now I'm going to show you, there's more than one approach here, of course, like there are many math problems, but the approach I'm going to adopt is the following, and I'm just going to give you an example, folks. We know that 169 is divisible by 13 because it's actually equal to 13 times 13, right? But watch this little trick here, and I proved this on another video. I'm not going to go into the proof of this. But what you can do, and I'll just use the arrow to denote this transformation, you can take 4 times the last digit and add it to what remains. That is, I'll just write it out. You can take 16 plus 4 times 9. But 4 times 9 is 36, and 36 and 16 is 52. And guess what? 52 is divisible by 13 because it's equal to 4 times 13. So 52 is equal to 4 times 13. And so without proving this, I've just shown you an example of what this does. The algorithm is to take the very last digit of your number, of your integer, multiply by 4, that's a magic number that comes up in the proof, add it to the preceding digits that remain. In this case, you get 16 plus 36 is 52, and it is a multiple of 13. And you can keep doing that forever and ever. Now, this was a trivial example, you know, this is 13 squared, but this works, period, for any division test for 13. So again, we're gonna employ this test repeatedly, and that's what I've done right down here below. Okay, so here's our original number with D located right here in the thousandths position. Notice that I dropped the 3, okay, and you see how we have 176D28? Just like we dropped the 9 right here, we dropped the 3, but then we didn't drop it in the sense we multiplied it by 4, and then that's 12, so 28 and 12 gives you this 40 right here, okay? So we still don't know anything about the divisibility by 13, but we do know we have a smaller number, right? This is 1 digit shorter. So in that sense, it's computation reducing, okay? Now, in a similar fashion, we drop the 0 here, and all we have is 4. Again, I wrote 4 times 0 just to not omit the algorithm, okay? So we get the same thing back. We still want to know if this is divisible by 13. So again, rinse and repeat. Drop the 4, multiply by 4 times 4, which is 16. Now, this is equal to 176D plus 16. And I got hung up a little bit here until I realized the approach was to rewrite it like this. 176D is the same as 1760 plus D, right? And you still have the plus 16 going on there. Now, here's where the only significant computation went on. This number right here is equal to 32 times 5 times 11. In other words, 1760, you have to take some time to determine its prime decomposition. It's 32 times 5 times 11. That's not too hard to see. And so we get it to this position right here, and we do have 16 as a common factor. We do have 16 as a common factor, which is what I did on this very next step. I factored a 16 out, all right? And then again, another big computation, if you want to call it that, 2 times 5 times 11 plus 1 is 111. Okay, so we're left with a much smaller computation, but what we know is that this object is divisible by 13. Okay, we know that it's divisible by 13, so all we have to do is pull out our modular arithmetic magic here. Now, divisible by 13 is the same thing as saying the object is congruent to 0 mod 13. Okay, and so what we can do right here is replace everything in here with what it's equivalent to mod 13. Well, notice what we get right here. We get 16 is congruent to 3 mod 13. Now, what about 111. Well, you just have to divide 13 into 111, which is not nearly as hard as dividing 13 into what we started with. Okay, but what do you get? 8 times 13 is 104, right? 8 times 13 is 104. That leaves a remainder. So we have 3 times 7. These two numbers reduce to 3 and 7 respectively when you divide each of them by 13. And again, this is easy to see. Also, just think of it as 16 minus 3 is 13. If you divide 7 into 111, if you divide 13 into 111, what did I say a while ago? 8. 8 times 13 is 104, and you have a remainder of 7. So we have this. Is congruent to 0 mod 13. I won't write that down. Okay, so y'all, what do we get right here? We get 21 plus D, and we're trying to, D needs to be something such that this will be divisible by 13. Is congruent to 0. All right? But this implies that D would be 5. D equals to 5, folks. And of course, that's because this would be 26 right here. 26, by inspection, 26 plus 5. There's a lot of D's that are, so 18 would be, but 18 is not a digit, right? So D is the only one that would be a digit, between 0 and 9 inclusive. So 26 is congruent to 0, mod 13. And D equals 5 is the answer, ladies and gentlemen. So I kind of like this problem. I think it may seem more tedious than necessary. Some of you may know faster ways. I think there's a way to do it directly just by noting that 13 is congruent to 3 mod 10 and working directly. That'd be a nice exercise to just try to work this out directly. This would be D times 10 to the third, right? And then you know how to, the expanded form. But anyway, we got D equals to 5. Thanks for viewing.